All right, today we're going to look at solving absolute value equations. Again, here are the standards that you need to understand and cover, and the success criteria that we are going to use to determine whether we are successful in learning what we need to from this lesson. So make sure you can write two linear equations related to a given absolute value equation. Make sure you can solve equations involving one or two absolute values and identify special solutions of absolute value equations. All right, some vocabulary that you need to know, and make sure you put these in your notes. Absolute value equation is an equation that contains an absolute value expression. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. All right, so an extraneous solution, another way to put that is when you solve an absolute value equation and you get an answer, you must check it to see if it works. If it come from the original equation, but when you plug it in and check it and it doesn't work, that's why it says you must reject it. It would not be considered a real solution. It would be an extraneous solution. All right, key ideas. These are properties that you need to be aware of. Let A and B be real numbers, then the following properties are true. Absolute value of A is greater than or equal to 0, okay? So in the past, I'm sure you've heard absolute value is distance from 0. You can't have a negative distance. So absolute value is going to represent a positive number, so a number greater than 0. Absolute value of negative A equals the absolute value of A. Absolute value of A times B equals the absolute value times the absolute value of B. The absolute value of A divided by B equals the absolute value of A divided by the absolute value of B, where B cannot be equal to 0. Remember, you can't divide by 0 or it's undefined. So that's why you have this special circumstance here. All right, so solving absolute value equations. To solve absolute value of AX plus B equals C, when C is greater than or equal to 0. So when this is isolated and it's equal to C, remember this has to be a positive number. All right, so you will set this up, AX plus B equals C, or AX plus B equals negative C. So to solve an absolute value equation, you have to set it up into two parts and solve each part, okay? All right, so it says if C is less than 0, the absolute value equation has no solution because absolute value represents a distance and cannot be negative, okay? So basically it's saying right here, this has to be greater than or equal to 0. If you have an absolute value equation equal to a negative number, that cannot exist, okay? All right, solving equations with two absolute values. To solve absolute value of AX plus B equals the absolute value of CX plus D, solve the related linear equation. So it'd be AX plus B equals CX plus D. So the same thing, all positive, or AX plus B, the left side stays the same, and you change the sign of everything on the right. So the negative is outside the parentheses to show that it distributes to the CX and the D. So let's try some examples. All right, solving absolute value equations. Number 1, absolute value of X minus 4 equals 6. All right, so the first thing I'm going to do is set up my two equations just like the property said. X minus 4 equals 6, or X minus 4 equals negative 6. All right, so I'm going to add 4, X equals 10, and I'm going to add 4, X equals negative 2. All right, you can plug these in quickly and check. 10 minus 4 is 6. Absolute value of 6 equals negative 6, so that works. Negative 2 minus 4 is negative 6. The absolute value of negative 6 is 6. So that one works as well. All right, so let's move on to number 2. Absolute value of 3x plus 1 equals -5. All right, this is isolated. It's equal to a negative number. Remember, it cannot be equal to a negative number because it represents distance. So number 2 is automatically no solution. You can't have a solution for an absolute value equal to a negative. All right, number 3, absolute value of x equals 10. So x equals 10 and x equals -10. All right, so that one was very easy. There was nothing to actually, no operations to have to take care of, but you can plug these in and check it. Absolute value of 10 equals 10. Absolute value of -10 also equals 10, so that one's easy to see that that is correct. All right, number 4, absolute value of 3 plus x equals -1/2. Again, this one's equal to a negative number, so there is no solution here. All right, solving a multi-step absolute value equation. All right, number 5 says the absolute value of 3x plus 9 minus 10 equals -4. So before we say no solution, we have to isolate the absolute value. So we have to add 10 to both sides. Absolute value of 3x plus 9 equals -4 plus 10 is +6. So this one we actually can set up and solve. So be aware if there's operations over here that you have to do first before you determine whether it has no solution or not. All right, now I can set this up as 3x plus 9 equals 6, or 3x plus 9 equals -6. Now we're going to solve both. Subtract 9 from both sides. 3x equals 6 minus 9 is -3. Divide by 3, x equals -1. All right, solve the other equation. So I'm going to subtract 9. 3x equals -6 minus 9 is -15. Divide by 3. -15 divided by 3 is -5. And again, we're going to plug this in to check it. So 3 times -1 is -3. -3 plus 9 is 6. Absolute value of 6 is 6. 6 minus 4 is -4 equals -4. So this one works. -5 times 3 is -15. -15 plus 9 is -6. -6. Absolute value of -6 is 6. 6 minus 10 is -4. So this one works as well. All right, I'm going to clear this off so I have room to work the next problem. All right, we're going to continue with number 6. Number 6 has 4 times the absolute value equals 16. So the first step here, since we have 4 times this, we have to divide by 4. So it's going to leave us with absolute value of 2x plus 7 equals 16 divided by 4 is 4. Then we can set up our two equations. 2x plus 7 equals 4, or 2x plus 7 equals -4. All right, subtract 7. 2x equals 4 minus 7 is -3. Divide by 2. X equals -1.5. All right, so subtract 7 from this side. 2x. -4 minus 7 is going to be, what, -11. Divide by 2. X equals 2 goes into 10 5 times, so -5.5. All right, so again, we'll have to check our solutions. So let's pull up the calculator to do that. All right, so we can just type this in the original problem here to see if it equals 16. The first one number we're going to plug in is negative 1.5. So we've got 4, okay, times, okay, if you go to math and scroll over ABS, that's absolute value is the first thing there. So we're going to have 2, and then I'm going to have times negative 1.5, and that's in parentheses because that's the x I'm plugging in, so I'm substituting this in for x, and then I have to have plus 7. And then I want to arrow outside the absolute value sign before I hit enter or done. All right, so that equals 16, so 16 equals 16. We can determine that the first one is correct. Let's do the same thing for the second one, negative 5.5. So we're going to do 4, and then math, over to number, ABS. We're going to do 2 times negative 5.5. And then we're going to do plus 7. Don't forget the rest of the equation here, plus 7. Then I'm going to arrow outside the absolute value. So I have 4 times absolute value of 2. X in this case is negative 5.5 plus 7. So we want to see if that equals 16 as well. And it does. So that shows that both of these are correct solutions. All right, I'm going to erase this so that we can look at the next example. All right, the last example on here is number 7, negative 2 times the absolute value of 5x minus 1 minus 3. Does that equal negative 11? So the first thing we want to do is add 3 to both sides, because again, we got to isolate the absolute value to even see if it's going to work. Right now it's negative, but it may not be once we isolate the absolute value. All right, so negative 11 plus 3 is negative 8. We need to divide both sides by negative 2. And we have 5x minus 1, or the absolute value of 5x minus 1 equals negative 8 divided by negative 2 is positive 4. So that gives us a positive C value or a positive constant value so that we know that we can now solve this as 2 equations. So I'm going to come over here to the left where we have more room. So let's do 5x minus 1 equals 4, or 5x minus 1 equals negative 4. Add 1 to both sides. 5x equals 5. X equals 1. All right, let's add 1 to this side. 5x equals negative 4 plus 1 is negative 3. X equals negative 3/5. All right, so we can plug that in to see if those two work for this original equation. So let's check these. All right, so I'm going to check 1 first. So I'm going to have negative 2. Do math, absolute value, 5 times 1 minus 1. Go outside the absolute value and then don't forget the negative 3. Okay, that one works. That one is negative 11, so that one works. So we're going to do negative 2, absolute value of 5 times, let's see, the other x we found was negative 3/5. So let's plug in negative 3/5. All right, make sure you plug it in correctly. All right, so negative 2 times 5 times 3/5, and then minus 1. go outside the absolute value, and then do minus 3.